Good evening, folks. In the previous lecture, we covered the basic concepts of cryptography. We got to know about the two types of cryptography, that is, the public key and the private key cryptography, and their differences and their use in today's world of the internet. Now let's switch to the next topic, and that is public key infrastructure, digital certificates, and digital signatures. Seeing this slide, first thing that comes to our mind is why we require the public key, infrastructure, digital signatures, or digital certificates. So here comes the reply. Let me tell you that the public key cryptography has some challenges. Now what these challenges are? As all of us know, public key crypto systems work with a unique key pair for each user, that is, a public key and a private key. So there can be two scenarios. In the first scenario, the public key is used for encryption and private key is used for decryption. Here the challenge is to verify the actual sender of the message. And in the second scenario, private key is used for encryption and public key is used for decryption. Here the challenge is the confidentiality of the message, as anyone can use the public key to decrypt the message and read it. Now the first challenge, that the user needs to trust that the public key that he is using in communications with a person really is the public key of that person and has not been spoofed by a malicious third party, is overcome through a system known as public key infrastructure, or the PKI, which consists of a trusted third party. This third party or certificate authority securely manages and attests to the authenticity of public keys. When the third party is requested to provide the public key for any communicating person X, they are trusted to provide the correct public key. The certificate authority satisfies itself about the user identity by the process of attestation, notarization, or some other process, that X is the one and only or globally unique X. The most common method of making the verified public keys available is to embed them in a certificate which is digitally signed by the certificate authority. Now let's start with some introduction to the PKI first. So in public key cryptography, a certificate authority creates a public and private key simultaneously using the same algorithm. For example, a popularly known algorithm is RSA. So the data encrypted with a public key can be decrypted only with the corresponding private key, which are called the encryption operations for confidentiality. And the data encrypted with a private key can only be decrypted with a public key, which are known as the digital signature operations for non-repudiation, or the integrity. So by non-repudiation, we mean that the sender's identity should be confirmed. Now the definitions. PKI or public key infrastructure is a set of comprehensive system policies, procedures, and technologies working together to allow secure and confidential communication between internet users. PKI is based on the idea of encryption using public and private keys. Public key is distributed publicly and a private key is kept secret. Public key is digitally signed by a third party known as a certificate authority. One of the two keys can be used to encrypt information that can only be decrypted with the other key. In this example, Alice encrypts the message with Bob's public key obtained through a certificate authority, and Bob uses his private key to decrypt the message sent by Alice. This system of digital certificates is called public key infrastructure. The implementation of a public key infrastructure is intended to provide mechanisms to ensure trusted relationships are established and maintained. Now let's come to the definition of digital certificates. Digital certificates are digital identities issued by trusted third parties that identify users and machines. Certificates are created on servers running certificate services and stored and administered in a central directory. For a user operating from home, the certificate will be stored on his system. A digital certificate provides assurances that a particular public key belongs to a specific entity. Now let's come to the example of digital signatures. Here Alice encrypts the message with her private key so that Bob can decrypt it with Alice's public key. Since the public key is, as the name suggests, publicly available, this is not a good idea if Alice wants to keep the message secret. An intruder can also simply obtain a copy of Alice's public key and this also decrypt the message. But because Alice keeps her private key to herself, Bob knows that only Alice could have encrypted this message. Bob can now be sure that this message was written by Alice. A signature on a paper message serves as a proof that this message was written by the person who signed it. Encrypting with a private key thus can be regarded as an equivalent to placing one's signature on the message. This is why this is called creating a digital signature for the message. So, the need of digital signatures arises for the verification of the key pair holder. And for digitally signing a message, the sender needs to encrypt it using his private key and the recipient can decrypt it using the sender's public key. So if Alice wants to keep the message a secret that only Bob is allowed to learn, she of course then simply encrypts the digitally signed message with Bob's public key. So what happens then? Then when the message comes to Bob, Bob then first decrypts the message with his own private key and then decrypts the result with Alice's public key. So he then knows that no one else could have read the message because it was encrypted with his public key, and that no one but Alice could have written this message because it was encrypted using her private key. Thank you.